Hello guys, welcome back to Nerdy Crew. So today we are solving another easy problem on arrays. Today the problem is that we have to remove duplicates from sorted array. So now let's start by reading the problem statement. Here we are provided with an integer array that is sorted in the non-decreasing order, meaning that it is in the ascending order, and we have to remove duplicates from that array such that the unique element appears only once and the relative order of the element should be kept the same. And then in the end, we have to return the number of unique elements in that array. You can read this statement further and you can also check out the examples provided here. Now let's start by understanding the approach. So take a look over this example right here. Here you have an array, and in order to remove the duplicates, the first approach which I can think of is declaring an array list. Once you have declared an array list, you can iterate through this array and only store the unique elements, right? So let's do that. So first I'm declaring this array list and I'll hold some integer values. List is equal to new array list, and then we have to iterate through this array. So int I is equal to 0. I will go on till less than nums dot length, right? So now while iterating, we can have a condition here which checks if the element that we are currently at is not equal to the element which is already added to the list. So for that I can say that if nums of I is not equal to list dot get list dot size minus 1. So this condition will allow only unique elements to be added in the list. So then I can say list dot add nums of, but understand that this condition won't hold true if your list is empty. So for that we can have list dot is empty. We can add this condition. Now this is basically our original array, and this is our array list with all the unique elements in it. Now all that you have to do is put back all these elements from your array list back into your array and let all the remaining elements in your array be the same. So your array will look like this. Basically you have to just manipulate your original array. So how can we do this? We can simply use a for each loop to iterate through your array list, and then eventually we can put the elements back into the array. So int j is equal to 0, and here comes the loop. Int k will iterate through this list. J plus plus is equal to k. Now you don't have to return this array, but you actually have to return the count of all the unique elements, which is actually the size of your array list. So we can do that by return list dot size. So let's just comment it out first and let's try to run it. It should work. Yeah, so accepted. You can try to submit it as well. It's working fine. So now let's analyze the time complexity. Here we are making n iterations, therefore the time complexity is going to be big O of n. And here, if all the elements in the array are unique, therefore here also we can have a time complexity of big O of n. Therefore the total time complexity is going to be big O of 2n, which implies that the total time complexity is going to be equal to big O of n, right? So this is what our time complexity will be. Now what will be the space complexity? We are having an array list which will store a maximum of n elements in case the array contains all the unique elements, right? So the space complexity will again be big O of n. So the next approach which I am thinking of is of using two pointers. Here we can have two pointer, which is I and j respectively, and I is pointing to the 0th index and j is pointing to the first index. Now we'll keep on moving the pointer I until we don't encounter an element which is not equal to the element at the ith position, right? So we have moved it. Now here we see that we encounter an element which is not equal to the element at the ith position. So what we do? We can simply increment the value of I, right? let's increment it. And after we have incremented it, we can simply change the value at this index. So therefore our array will look like this. And then eventually we can just move on the pointer of j. So then what we have to do, again we'll follow the same step. We'll move on the pointer of j. Now again we see that the element at the jth position is equal to the element at the ith position. So the pointer j will keep moving. Now we come across this element which is 2, and this element is clearly not equal to the element which is at the ith index, that is 1. So now what are we going to do? I can simply move the pointer I again, and once I have moved it here, I'll replace the element at the ith index with the element that is at the jth index, and then the pointer j will move forward. Now again we'll keep it moving forward. So now again we come across a situation when this element is not equal to the element at the ith index. So what we do? We've moved the pointer I, and then we'll replace the value here with the element that is present at the jth index, and we move this pointer j again. So now again we have an element 3, and this is equal to the element at the ith index, so we'll move it further. Now after we have moved it here, we see that again this element at the jth index is not equal to the element which is present at the ith index. So what we do? We move on this pointer I, right? Let's bring it back to its place. And what we do? We replace this element with the element that is present at the jth index. And since we have reached the end of the array, so this loop is going to break. So this is how we do this. So now let's code it. So first off, let's initialize a variable I which will be equal to 0 and a variable j which will be equal to I plus 1. Now after initializing it, let's start a while loop which will run till j is less than nums dot length. Now we'll only have two conditions. The first condition is going to be if nums of I is not equal to nums of j. In this case, you can simply say that increment the value of I, then replace the value of nums of I as it will be equal to nums of j. And once this is done, we can simply increment the value of j. Now if this condition is not hit, the only other condition is going to be increment the value of j. Now once this is done, we can simply return I plus 1. So now let's try to run it. Yeah, it's working fine. We can submit it as well. So now let's analyze the time complexity. Here the loop is running for n elements, therefore it is going to be big O of n, and we are not taking any extra space, therefore the space complexity is going to be big O of 1. So I hope that you have understood this lecture. If you like the video, please make sure that you like, subscribe and share it with your friends. Thanks for watching.